Okay, so Assalamualaikum warahmatullahi wabarakatuh. Good evening everyone. Tak payah gitu membetulkan. Apa panggil strike untuk line tu. Memang dia tak clear sebab belakang dia sepatutnya green screen. Tapi dia tak duduk betul-betul sebab dia terjatuh. So tu yang jadi macam tu. Nak baca separuh je kan. Kesian aku green screen pun boleh jatuh. Whatever. Okay, next. Actually stop at the quartile and percentile for group data. So let me finish that one first. Oh, hi Fatha, hi Aisha. So let me finish the quartile and the percentile for group data, and then we will proceed with lecture 3 of 3 for chapter 6. Kesian dengan tudung saya warna hijau, dia masuk sekali oh. Whatever. Okay. Okay, so now let us proceed. Okay, so quartile for percentile, quartile for percentile. For group data, okay, so the formula is QK equal to LK plus K over 4N minus FK minus 1FK multiplied with CK. Okay, so this is almost similar to what we have in median, except that this one is N over 2 for a median. So kalau untuk median, we are using N over 2. So for the quartile, it will be K over 4 multiplied with N. If this is for a percentile, then it's supposed to be K over 100 multiplied with N. Okay, so the rest will be similar. So LK is for the lower boundary of the class. And then F, the cap F stand for the cumulative frequency. The small f is the frequency of the class. And then C is actually the class size. So we do have a few things that we need to calculate. Okay, next. Mana dia pergi? Tak ada dah, hilang dah. Right, so this is the formula for the percentile. Like I told you before, this is K over 100 times with N. So almost similar to the median, except that this is K over 100. Okay, so everything else will be similar. So we just need to know where does the class lies, and then we're gonna calculate everything. Kena tahu kelas ni dulu lah. So make sure you be ready with your calculator as well as your highlight. Okay, so the first quartile, so this is actually 25th percentile, or you can say that Q1 is equal to P of 25. And then second quartile is the median, and that is the 50th percentile, so this is P50. And the third quartile is percentile, so this is P5. So the interquartile range, which is the IQR interquartile range, is the range between the first quartile and the third quartile. Okay, next. For the frequency distribution given below, so we have a interval and the frequency. Find the mean, the mode, the median, the first quartile, so that means Q1, the third quartile, Q3, and then we have to calculate what is the interquartile range. So interquartile range, so this is Q3 minus Q1. So once we know what is the third and the first quartile, we can simply find the difference between them. And then the 10% should be 10. And then the value of M is 30% of the data is greater than M. Okay, so we have our total data over here. So let's say this is 100% of our data. So M is somewhere over here, and it say what is the value of M is 30% of the data is greater than M. So this one over here is 30%. So 30% of the data is greater than M. Okay, tapi saya rasa macam M kena ke sini sikit lah. Nampak macam besar sangat wang dia. So sekejap. Saya buat kecil sikit. Lah nanti tak skill korang bising lah. Okay, this one 30%. Okay, so for this one, this simply means we have to calculate what is the percentile. So the percent we calculate from the earlier until the M. So M is actually P of 70 because we want to find out what is the 70% value from here to here. So that will be the value of m. Okay, so let me go on how to calculate the mean. Right, so of course you need to have quite a bit of data. So the class boundary, that is fine. If you don't want to calculate them, just make sure to have your midpoint as well as your cumulative frequency. So let me go faster. So the midpoint 20 plus 29 over 2, so 24.5. And then 30 plus 39 over 2, so 34.5. 40 plus 49 over 2, so this is 44.5. 50, 59 over 2, so this is 54.5. 60 plus 69 over 2, so this is 64.5. 70 plus 79 over 2, so this is 74.5. 80 plus 89 over 2. So this is 84.5. So the cumulative, so we always start with our frequency here, which is 4. And then you add with 11 because the frequency here is 11. So adding with 11. So this one is equal to 15. And this is 20. So we're going to add 20 here. So 15 plus 20, 35. And then of course, add another 45. So this is 80, 80, and then we're going to add with 25 because the value here is 25. So this is 105. And of course, with 12. So this is 117. And then plus with another 3. So that is 120. Okay, so this is our total frequency, which is 120. So the question asks for us to calculate the mean, median, and mode. Okay, so I guess better for us to start with the mean first. What is the formula for the mean? So that is actually the summation for fx over the summation of f. Oops. Okay, so for x, you times them with f. So multiply everything and take the sum of it. So that is the summation for x. Of f is this one over here, 120. So I guess to make it easier, it will be easier if I calculate the value for you first. Then you can easily calculate them on your own. Okay, so the value for summation for fx, so this is 6580 divide with the total frequency 120. So simplify them. So the mean is 54.83. So this is how we calculate the mean. Okay, so second, we have to find out what is the median. So ready with your highlight. Okay, so what is the formula for the median? Okay, so basically for the median, we need to know first where is the n of 2 because we want to highlight the class. So n over 2 is actually 120 over 2, which is equal to 60. So let us refer to our cumulative frequency and see where is 60. So cumulative frequency 60, so 60 is definitely inside here. So this is the class that will give us the median. So this is the median class. So our calculation will depends on this class. Okay, so let us refer to the formula then. Oh, dia suruh mode dulu ke? Tak apalah. If it is for mode, then you have to refer to the highest frequency. Tapi ignore dulu lah mode tu. Kira median dulu. Okay, so the class containing the median is the fourth class, just like what we have earlier. So this is the lower boundary of the class, which is 49.5 plus n over 2. So this is n over 2 minus, this is fk minus 1. That means the cumulative frequency before our class. So if you refer to your highlight, the frequency, the cumulative frequency before your class. Okay, so this is your in class. The cumulative before your class, so that is actually 35. So this is fk minus 1. And then divide with the frequency of your class. So your class, the frequency is 45. Okay, so the class size. So take the upper boundary minus with the lower boundary. So 59.5 minus 49.5. So the answer is 10. So this is C. So I repeat, the formula is LK plus n over 2 minus FK minus 1 over FK times with C. So LK is the lower boundary. So the lower boundary for our class 49.5. N over 2, so N is the total frequency, which is 120 over 2 minus cumulative before our class. So this is your median class. Check the cumulative before your class. So the value is 35 over the frequency for your own class. So check what is the frequency for your class. And then times with the class size or the class width. So do make sure to take the upper boundary minus with the lower boundary. So that is our class size, which is 55.06. Okay, so let me go back to the mode. Okay, so for the mode, we have to see or we have to refer to our table which one that has the highest frequency. Okay, so kita patah balik pergi yang tadi tu. Okay, so this one seem a little bit messy, so let me erase a little bit. Okay, now let us see where is the mode. Okay, so the mode depends on the highest frequency. So the highest frequency is 45. So just now you are using one highlight, right? So now use another highlight. So this is the mode class. So please highlight this one. That will be much more easier. Okay, so what is the formula for the mode? The formula for the mode is LK plus D1 over D1 plus D2 multiply with C. Okay, so what is D1? D1 is actually the difference between your frequency and the one before you. Okay, so this is your frequency, the one before you. So this is D1, your frequency, and the one after you, this is D2. And then of course you need to take the class size. Okay, the class size will be 59.5 minus 49.5. So the class size is actually equal to 10. So D1, don't forget you have to minus them. So the lower boundary for this class is 49.5. The D1 is 45 minus with 20. D2 45 minus with 25. And then C is 59.5 minus 49.5. Okay, X. Put into the formula. So it will become 49.5 plus 25 over 25 plus with 20 multiply with 10. So that will give us 55.06. Oh, by the way, hi Diza. Tak perasan tadi. Okay, next. Median dah kira. Next. Okay, so now we have to calculate the first quartile. So the formula for the quartile is LK plus K over 4 times with N minus FK minus 1 over FK times with C. So I need to know where is the first quartile. So again, go back to the table, do highlight where is your quartile. Okay, so I guess let me highlight for both the third quartile and the first quartile because we have to calculate for both. Okay, so we have n equal to 120. So for the first quartile, I need to 1 over 4 multiply with 120. So 120 divided by 4, so this is 30. So use one highlight in order to like 30. So 30 is somewhere along here. So this is the class for your first quartile. For your third quartile, Q3. So for this one, it's supposed to be 3 over 4 multiply with 120. So 30 times with 30. So I'm supposed to find out where is 90. So 90 is over here. Okay, so this is basically the calculation for my third quartile. So do make sure to highlight. So kalau nak buat data, biasanya saya ada banyak lah highlight saya. Ada berapa? Biasanya ada banyak color lah. Biasanya ada 3 ke 4 color entah untuk highlight saya. Okay, so now let us refer to the formula now. Okay, so this is in the third class, 39.5 until 49.5. So 39.5, 1/4 times with 120 minus with the cumulative frequency before our class, which is 15, over with your frequency, 20 times with the class size. So this is equal to 47. The third quartile, so just now we already calculated. So this is in the fifth class. The boundaries is 59.5 until 69.5. So 59.5, 3/4 times with 120 minus the cumulative frequency before your class and then over the frequency of your class times with the class size. So for this one, oops, the value is 63.5. So the first quartile, the third quartile. So do make sure to highlight them first. It will be much more easier to handle them. Azrin Azhar, good afternoon. Good afternoon. I never saw you before. Are you in my class? Okay. So I already calculate the first quartile. I already calculate the third quartile. So now we have to calculate what is the interquartile. So the interquartile is equal to Q3 minus with Q1. So you simply take 63.5 and then you minus with 47. So the value over here will be our interquartile range. Let's go. Okay, so the value for your interquartile range is 16.5. Okay, so just now I already talked about the percentile where I already told you that I'm going to calculate where is P70. Oh, dia minta P10 dulu lah. Okay, tak apa, 10 percentile. Okay, so 10 percentile, do make sure to calculate first where is the observation. So just like what we did for the quartile, so go back to the table and find out where is that thing. Oh, kena patah balik table. Banyak ya. Okay, again, I have to repeat the same thing but this time for the quartile. Okay, no, percentile. Okay, P of 10. So do make sure to calculate 10 over 100 times with your total number of data, which is 120. So cancel, 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 cancel. So you have to see where is the 12. So 12 is actually in your second class. So this one, we are going to use them to calculate P of 10. And then another one, I want to calculate what is the value M, right? So I told you it's supposed to be P70. So kita kira siap-siap boleh tak? Sebab leceh lah nak patah balik nanti. So 70 times with 100 multiply with 120. So cancel, cancel, cancel. 12 times 7, what is that? 4,184. So 184 gonna be in 60 to 69. So this is how or when I want to calculate M for this one. Okay, next. Okay, so P10 is actually in class with boundary 29.5 minus 39.5. So let's make for that class is actually cumulative for your class, for your own class, and size. So the answer for this one is 37. I'll go a little bit fast, you know. So like before, we already calculate earlier Okay, so sorry for that. Tak tahu lah kenapa saya rasa line saya kan dia memang macam semenjak 2 menjak ni kan dia macam jealous gila kalau saya buat live tau. Dia macam kalau waktu hari biasa dia macam okey je, tiba-tiba je masa live je mesti macam nak cancel. Suka hati je. Okay, so now I want to test first. Are you guys listening? And why did we stop actually? Have I already explained the H for you? Yang P70 ni dah explain ke belum? Serius tau Aisyah, dia memang jealous gila kalau kata saya online. Mesti nanti macam nak apa, tiba-tiba je lagging lah, off lah apalah. Tengok saya pakai Celcom je, masuk laju je, sabar je lah. Nak juga aku pakai data, habis sikit aku. Okay, so what about H? Have I explained the H? Not sure. So dekat mana dia hilang? Okay, tak apalah macam ni lah. Let me know where did I stop. If I haven't done anything on H, let me know lah. Sekejap lagi. I better start with the next one first. And then if we have the time, let us go back to that question. Dia ni memang jealous dah lah. Terkejut tiba-tiba hitam. Itulah. Muka awak je terkejut dengan saya sekali terkejut. Okay, tak apa. Never mind. Let them jealous. Okay, so now this is the last lecture for data description. So basically I have already covered the measure of location. So this is the measure of dispersion. 6.3, the measures of dispersion, where we are going to calculate the variance, the standard deviation, and then something called the Pearson coefficient of skewness. I'm sure for some of you that might seem a little bit weird because you never heard of them before. But for standard deviation and variance, I'm sure you are quite good with them. Okay, so next, let us proceed. Okay, so the learning outcome, you should be able to find and interpret the variance and standard deviation for the ungrouped data. So we have two, ungrouped and grouped data. So remember last time I asked you to fold your A4 paper into half. So one side will be for the ungrouped, another side will be for the grouped data. That will help you a lot. And then find and interpret the variance and standard deviation for the group data. And then find and interpret the Pearson's coefficient of skewness. So we're going to see if we get something with positive, what does it mean for the skewness? If we have a negative value, what does it mean for the skewness, and so on. Okay, introduction. Two sets of data might have the same mean value but may differ in their dispersion. So we want to see how far they are from the mean value. So they might get the same mean, but it might be far from the mean compared to the others. For example, in the following set of data, okay, so we have A and we have B. Okay, so for both of them, we actually have the same mean, which is 25. So you can actually calculate for both A and B. So the mean is 25, but most of the number in the first set are around the mean. So you see for this one, this is 20 plus. So this is around our mean, which is 25. For this one is quite different from our mean because we have up until 60 and then we have a very small number which is 2. So this is quite far from my mean. Okay, so on the other hand, the second side is more spread away from the mean. So this is basically how you want to draw them. So this is set A and this is set B. They are more dispersed. So this is the mean, 25. As you can see, for set A, they are just around the mean. But for set B, they are more far away from the mean, or we're going to call them as more dispersed. Okay, so the difference in the spread of data can be determined by the measure of dispersion. So you can actually calculate them. So two common measure of dispersion are the variance and standard deviation. So if we're referring to the set A and set B, the value of the variance for set A is definitely smaller compared to the value for set B. A bigger value of variance or standard deviation means that the data are more spread out about the mean and less consistent. So that is why I say that the variance for set B is larger compared to set A. Okay, so variance and standard deviation for the ungrouped data. So for the ungrouped data, the formula, so variance normally denoted by S square. So this is the summation of X square minus the summation of X square over N minus 1. Okay, so what is the difference between these two? Okay, so for this one, this is the summation for X square. That means for each X, you should square them first before you add them. Meanwhile, for the second one, for this one, you should add all the x first before you square. So it's either you square first before you add or you add first before you square. So basically for summation of x squared, it simply means that we square everything first before we add them. And the second one, we simply add everything together before we square. Okay, so the standard deviation is simply the square root of our variance. So whatever your variance is, simply take the square root of them, and that is actually the standard deviation. Okay, next. Right, so this one I think you might need to write them down or you can screenshot them. So if a constant C is added to each value of the data, so if let's say I have a data and suddenly I want to add a new constant for them. So I add the same constant for each of the data. So let's say I start with 1, 2, 3, 4, 5. So this is the old one. So for the new one, I said, why don't I add 7 to each of them? So 1 plus 7, 8, 9, 10, 11, and 12. Okay, so this is the old one. This is the new set of data. If let's say I'm calculating the variance, then the variance for the new one is actually equal to the old one. The standard deviation for the new one is actually equal to the standard deviation of the old one. So dia akan sama sajalah sebab variance is all about the spreadness. So if you add some numbers, it will be the same spreadness. Sama sajalah sebab kita consistent, kita tambah nilai. If a constant C is multiplied to each value of the data, so let's say the old one is 1, 2, 3, 4, 5. So now the new one, if let's say I want to times everything by 2, so this is 2, 4, 6, 8, 10. So the new variance will be equal to C square multiplied with the old variance. And the new standard deviation is the modulus of C times with the old standard deviation. So this is something that you need to know. Okay, so let us proceed straight away to the calculation. This is actually the properties of variance and standard deviation actually. Okay, next. Find the mean, variance and standard deviation for the data below. So we have 2, 7, 10, 9, 2, 5, 16. Okay, so we have to calculate the mean first. So the mean or the x bar is the summation for fx over the summation of f. Summation. Summation of x over n. Terlupa. Tadi kan buat ungroup data. So summation of x over n. Okay, so do make sure to add everything first to get summation of x. And the number of data is 1, 2, 3, 4, 5, 6, 7. So n is actually equal to 7. Okay, so add everything together, divide them by 7. That is actually your mean. In order to calculate your variance, you have to calculate what is the summation of x square as well. So for each of them, square them first and then add them together. So that is the summation of x square. So we will need two value, the summation of x as well as the summation of x square. Okay, so to make it much more faster, better for you to use whatever value that I calculate here. Okay, so I already calculate them for you. The summation of x is 51. The summation of x square is 519. Okay, so now the mean. The mean is summation of x over n. So that is 51 over 7. So this is 7.29. So this is the mean. The variance, the formula is summation of x square minus summation of x square over n minus 1. So the summation of x square is 519. Summation of x over here is 51. So we got 519 minus 51 square over 7 over 7 minus 1, which is 6. So calculate the variance, and the answer for this one is 24.57. Next, you have to calculate the standard deviation. So that is actually the square root of your variance. So the standard deviation is simply the square root of 24.57. So the answer for this is 4.96. So variance, standard deviation. Okay, next, let us go to the next example. Okay, the following is the systolic blood pressure in millimeter Hg apa, tak ingat dah. Dulu ada cari. Of 10 patient in a hospital. So we got 165, 135. That's quite high actually. 151, 155, 158, 146, 149, 124. This is quite okay. 162, 173. Find the mean and the standard deviation of the systolic blood pressure of the 10 patient. Find the number of patients whose systolic blood pressure exceed one standard deviation above or below the mean. Okay, so let us read carefully. The first one, find the mean. So you have to know what is the mean or x bar. So this is summation of x over n. So we got to calculate the summation of x. The standard deviation, so I have to calculate the variance first. And then we're going to take the square root of the variance in order to calculate the standard deviation. Okay, so for B, find the number of patients whose systolic exceed one standard deviation above or below the mean. So we need to make some interval over here. So it's supposed to be either above or below the mean. So if let's say this is my mean, this is my mean, or your x bar. So this one plus with our standard deviation. This one is minus with standard deviation. This one is plus the standard deviation. So that is what they mean. Either above or below the mean. Okay, next. Let us calculate the sum of x and sum of x square. Okay, so n is equal to 10. Sum of x is 1518. Sum of x square is 232306. So do make sure to write them down first. And then the mean is sum of x over n. So 1518 over 10. So the answer will be 151.8. And then you need to calculate what is the variance and take the square root of the variance to calculate the standard deviation. Okay, so that is the square root for summation of x square minus summation of x square over n minus 1. So substitute the value for this one. This is 232306. Sum of x is 1518 square over 10 over 9. So the standard deviation is 14.43. Okay, so that is for A. And then of course for the second one, we have to do the interval for them. Salin dulu tak? Salin dulu lah. Bagi saya minum je. Okay, hopefully done. If you still haven't calculate everything yet, please pause the video. Okay, the next one. One standard deviation from the mean. So I'm going to add one standard deviation and then minus one standard deviation from the mean. Okay, so 151.8 minus 14.43 and then 151.8 plus 14.43. So the interval is from 137.37 until 166.23. So based on the data that we have earlier, which is the 10 patient, so do see which one that is outside of them. Okay, so the first data I have is 135. So this is totally outside of them. And then another one, this one is okay, inside the interval. 151, that is also inside the interval. Oops. 155 also inside the interval. 158 also inside the interval. 146, yep. 149, yes. 124, I don't think they are inside the interval. So no. 162, they are actually inside the interval, so that is okay. 173, that is totally outside of the interval. So altogether, we have 3. So the number of patients with systolic blood pressure outside of this range is 3. Okay, next. Right, so this is the variance and standard deviation for group data. So this is the summation for fx square minus summation for fx square over n minus 1. Okay, so this one, it simply means that you have to calculate f times x first before you add everything together to get summation for fx square. For summation for fx squared, it simply means that you have to calculate f times with x, add everything together first before you square them. Okay, so the standard deviation, again, it is the same thing. So we simply need to do the square root of our variance. So that is our standard deviation. Okay, so now, example 3. The frequency distribution table shows the mass of loaf of bread produced by a bakery. So we got a mass, we have a frequency, find the mean, the variance, and standard deviation. Okay, so how to calculate the mean? Yang ni baru betul lah. Summation for fx over summation of f. So I need to know the frequency, which is already over here. And then I need to have the midpoint. So I don't have the midpoint yet. So I have to calculate what is the midpoint. Okay, so you're going to add these two together first and then divide them by 2. So that is the midpoint. So the x over here is 422, 427. This is 432, 437, and 442. So that is the value of x. So in order to get summation for fx, so we simply take the x times with the f. So after that, we're going to add everything together to get the summation for fx. Okay, so again, let me calculate that for you because it's going to take ages if you're going to use your calculator. Okay, so the midpoint. Right, so n is equal to 100. The summation for fx is 43180. The summation for fx squared is 1864947. So calculate the mean first. The mean is the summation for fx over n. So it's supposed to be 43180 over 100. So this is 431.8. So this is the mean, which is 431.8. So now we got to calculate what is the variance and standard deviation. Okay. Variance, the summation for fx squared minus summation for fx squared over n minus 1. Okay, substitute the value in. And this is 43.90. The standard deviation is actually the square root of your variance. So this one is 6.63. Oh, by the way, data dia memang a little bit dull actually because it's simply the same thing, right? So you just need to calculate your frequency, your midpoint, summation for fx, summation for fx square. So please do understand if it seems a little bit dull. Sebab dia memang calculation je, dah masuk dalam formula, lepas tu settle. Okay, so I think I'm done with part A. So let us see what is the question for part B. So let me go back to the question and let us read them together. Okay, so the bakery allow only loaf of bread, each with a mass within one standard deviation from the mean. One standard deviation from the mean to be sold in the market. Find the interval of mass of the loaf of bread allowed to be sold. Okay, so it's supposed to be one standard deviation from the mean. So this is my interval. So one standard deviation from the mean. So if this is my mean, then I should add with my standard deviation. Oh, but that one should be on the right hand side. So minus and then x bar plus with the s. Okay, so we already have the value of the mean just now. So you simply minus with your standard deviation. And then another one is your mean plus with your standard deviation. So that is the interval. Okay, so 431.8 minus 6.663 and then 431.8 plus 6.63. So the value is 425.17 and then 438.43. So that is the interval that we want to find. Okay, next. Interval of the mass of loaf of bread allowed to be sold in the market is between 4 to 5.17 gram and 438.43 gram. Just ayat je lah, nak tukar daripada huruf number tu pada ayat. Okay, next. The frequency distribution table shows the hourly wage of workers in a factory. So that is the wage. Okay, so 5 until 7, 8 until 10, 11 until 13, 14 to 16, 17 to 19. And the frequency is 9, 16, 11, 8, 6. Find the standard deviation correct to 3 decimal places. So they simply ask for the standard deviation. So that means you have to calculate what is the sum of fx square, the sum of fx, as well as what is the value for the n, or the total frequency. So you have to calculate all those things. Okay, so calculate the midpoint first. So do make sure to have the midpoint. 5 plus with 7 over 2. So that is the first midpoint. And then 8 plus 10 over 2. 11 plus 13 over 2. 14 plus 16 over 2. 17 plus 19 over 2. So that is the value for your x. So let me draw another table so that it will look much more clearer. Okay, so 5 plus 7 over 2. So the answer is 6. 8 plus 10, so 9. And then this is 12, 15, and 18. Okay, so after that, you have to calculate what is the summation for fx and summation for fx square. So the value for summation for fx is 558. Summation for fx square is 6948. So now substitute everything into the formula for the standard deviation. Make sure to write down the square root. Okay, so the square root of summation fx square minus summation for fx square over n minus 1. So the square root of 6948 minus 558 square over 50 over 49. So the standard deviation is 3.835. So that is the standard deviation. Sebenarnya kalau chapter 6 tak boleh jawab, then most likely you didn't know how to use your calculator. So always make sure you know how to use your calculator well. Okay, so I think I'm done with part A. So let us see what's the question in part B, because I didn't read the question just now. Bila banyak sangat biasanya saya lupa. So sebab tu saya buat sikit-sikit lah. Okay, so now if the manager of the factory decide to increase the wage of each worker by 20%, find the new standard deviation. Okay, so for this one, you have to use the properties that I give you. Excuse me. Okay, so we will increase by 20%. So we have to know what is that value. And then we have to calculate what is the new standard deviation. Oops. Okay, so the new standard deviation. Okay, so basically the changes will be 1.2 multiply with your standard deviation. So 3.835. So this one is supposed to be 4.602. So just now what did I say? If the data is multiplied by C, then the standard deviation is C times with the old standard deviation, right? Okay, so now this is, let's say this is your data, the old one. The old one, I have, I think something like 7, 9, 11, and 13. Let's say something like this. Okay, so now the new one, they said that they will increase 20%. Okay, so find out what is the 20% from 7 and then you add them to the 7. So that is why this is similar to 1.2 multiply with 7. So you're going to do 20% times with 7 first. So this is the increased amount. So the new wage is the 7 plus with the 20% times with 7. Or you can say that it's supposed to be 1.2 times with 7. And then the new wage for this one is also 1.2 times with 9. So this is 1.2 times with 11 and then 1.2 times with 13. So for each of them, I actually need to times them by 1.2. So since I'm multiplying with a constant C for each of the data, it simply means that my new standard deviation is equal to C multiply with the old standard deviation. So you can actually refer to the note that I give you just now. Yang ada warna pink-pink tu kan. So the C is 1.2 times with the old standard deviation. So the new one is 4.602. Okay, next. Symmetry and skewness. So we want to proceed with the Pearson coefficient of skewness. So that is why, again, we have to repeat about the symmetry and the skewness. So basically, if the mean is equal to the median, equal to the mode, then the distribution is symmetrical. So if you draw your box and whisker, the distance will be equal. The whisker will be equal as well. So this distribution is called symmetrical. If the mode is lower than the median, lower than the mean, then this distribution is skewed to the right. If the mean is lesser compared to the median, compared to the mode, then the distribution is skewed to the left. Okay, so now this is the Pearson coefficient of skewness. So sometimes, Q, Miss, you can repeat please. Sekejap hai. Yang ni nak suruh repeat soalan mana Hai nak suruh saya repeat yang mana satu? Tiba-tiba je okey. Nak repeat yang mana hai. Kesian awak, laju sangat saya. Sebab saya nak kejar chapter 7 tu, sebab tu dia laju sikit. Your name? What do you mean? Okay, never mind. Okay, so now Pearson coefficient of skewness. Benda lain yang bergerak, sabar je lah. I don't understand. Okay, so the Pearson coefficient of skewness is given by, okay, so we actually have two formula for the Pearson coefficient of skewness. So SK is equal to 3 times with the mean minus median over the standard deviation, or another one is the mean minus the mode over with the standard deviation. So you actually have two formula. So you can actually see which one that you should use. So kena tengok lah, kalau if let's say the question asks for the median and the mode first, then you might want to use this one. If the question asks you to calculate what is the mean and the median and hence calculate the Pearson coefficient of skewness, then you might want to calculate on the right hand side. Okay, so either one, if you use them, you are going to get or you're going to come to the same conclusion for the Pearson coefficient of skewness. So if let's say on the left hand side you have something with a negative value, that means if you are calculating the mean minus with the mode, this is also a negative value. If you are calculating something with a positive value on the right hand side, so if you are using the mode, this one should also be a positive value. So it cannot be one of them is positive, another one is negative. So it must be equal. The value might not be the same, you know. So this one might give you around, let's say, positive 0.5. This one might give you around positive 0. Let's say 0.61 or something. So it might be different, but the sign will be similar. Okay, so now let me proceed with the calculation. Okay, so if SK or the Pearson coefficient of skewness is less than 0 or a negative value, then the data distribution is skewed to the left or skewed negative, or normally I call them as negatively skewed. So if you have SK that is less than 0, normally I call them as negatively skewed. If I have SK that is greater than 0, then this one I normally call them as skewed to the right or positively skewed. If SK is equal to 0, then the data distribution is symmetrical. So the mean is equal to the median and that is also equal to the mode. SK less than 0 that is negatively skewed. Saya malas nak tulis panjang, so saya tulis pendek. So sekejap Kesian pula dekat awak. Okay, so negatively skewed. You cannot hear me? Oh my. If SK is less than 0, this is negatively skewed. So funny. If SK is greater than 0, this is positively skewed. If SK is equal to 0, then this is called asymmetrical. Or you can see that your mean is actually equal to the mode and this is actually equal to your median. So that is why we're going to call them as symmetrical. If let's say SK is in between negative 0.1 and 0.1, then the term slightly is used. So let's say your SK, for example, if let's say you calculate and then you get 0.05, then you must write down slightly, betul ke saya je ni? Slightly positively skewed or slightly skewed to the right. So you must use the word slightly. The same thing with negative 0.05, slightly negatively skewed. Tak sure lah grammar dia betul ke, tapi tak apalah. Okay, example 1. Given the following sorted data, find the mean and median, hence calculate the Pearson coefficient of skewness. So like I told you before, we have two formula, right? So we either have something with the mean and the median or something with the mode. So since the question asks for you to calculate the mean and the median, then in order to calculate the Pearson coefficient of skewness, we have to use both the mean and the median. Okay, so now let us calculate the mean and the median. You didn't understand? Just now, right? Okay, so the SK is in between 0.1 and 0.2. So this is your SK. This is negative 0.1. This is 0.1. If you have something in between this value, then you're going to use the word slightly. It must be slightly in front of them. So you might want to say that something like slightly skewed to the right or slightly skewed to the left. You need to have this keyword, slightly skewed to the right or slightly skewed to the left. Depending on the value of SK, if your SK is positive, then slightly skewed to the right. Negative, slightly skewed to the left. That is only when the SK is in between negative 0.1 and 0.1. Okay, so now let me go back to this example, calculating the mean and the median. So in order to calculate the mean, for this one, I have to do the summation of x over n. So we're going to add everything first before we divide with the total number of data. Okay, so I'm going to calculate that for you. Okay, so the n is equal to 10. The summation of x is 24.8. And the summation of x squared is 67.52. Okay, so now let us calculate what is the mean. Okay, the mean is summation of x over n. So this is 24.8 over 10. So the answer for this one is 2.48. And then another one, you have to calculate what is the median. Okay, so in order to know what is the median, you have to... The class will finish in 12 minutes. Once I finish this one, we will rest first before I proceed with chapter 7. Okay, never mind. Okay, guys, we want to calculate the median. So firstly, let us see whether do we have everything in ascending order or not. As you can see, we already have them in ascending order. So this one is okay. Next, you have to know the n is equal to 10. So this is actually an even number. So for the even number, the median, that will be n over 2 plus n over 2 plus 1 term. And then we're going to divide them by 2. Okay, so the n is equal to 10. So n over 2 is simply 5. So I have to see where is the fifth term plus the sixth term. And then I need to divide them by 2. Okay, so this is the first term, x1, second, third, fourth, fifth. So my fifth term is 24. My sixth term is 2.5. Oh, sorry, just now 2.4. And this is 2.5. So 2.4 plus with 2.5 and then divide them by 2. So this is 2.45. So that is actually your median. Okay, so now let us calculate the standard deviation, even though the question didn't ask us to calculate the standard deviation, but you will need them in order to do your, what you call it, the Pearson coefficient of skewness. Sorry ada message disturbing sikit. Okay, so now the standard deviation, that is the square root of x squared, the square root for summation of x squared minus summation of x squared over n minus 1. Okay, so I already have the summation of x squared, which is 67.52, minus the summation of x, which is 24.8. You square them, and then divide by n, which is 10 over 10 minus 1, which is 9. Okay, so the value for your standard deviation is equal to 0.818. Okay, so this is the standard deviation. Now let us calculate what is the Pearson coefficient of skewness. Okay, so the Pearson coefficient of skewness by using the mean as well as the median, the formula is 3 times the mean minus with the median over the standard deviation. So I have already calculated the standard deviation just now. So we're going to substitute the value inside here. So this is 3 multiplied with 2.48 minus 2.45 over 0.818. So the value will be 0.11. Okay, so what we can say over here, this is a positive value. So this is definitely skewed to the right. Or you can say that this is positively skewed. Okay, so done with this one. Next. Example 2, the frequency distribution of 80 patients. So I already have the n. The n is equal to 80. So we got the age, we got the number of patient. So find the mean and the mode. Hence calculate and interpret the Pearson coefficient of skewness given that the standard deviation is 6.798. Yes. Okay, so basically they already give us what is the standard deviation or the SD. So that means we don't really need to calculate them again. Okay, so now find the mean and the mode. So basically this is a group data. So I have to see what is the midpoint for each of them. And then I have to calculate what is the summation for fx as well as the summation for fx square. Tapi since tak perlu cari standard deviation, ni tak payahlah. Kita cari summation for fx je. Okay, the midpoint. So 10 plus 15 over 2, 15 plus 20 over 2, 20 plus 25 over 2, 25 plus 30 over 2, 30 plus 35 over 2, 35 plus with 40 over 2. Okay, so do make sure to have the midpoint. Okay, so this is 12.5, 17.5, 22.5, 27.5, 32.5, and then another 37.5. Okay, so in order to calculate what is the mean, we have to calculate summation of fx over the total frequency. So n is equal to 80. The summation for fx is 1985. So the mean is the summation for fx over n. So this is 1985 over 80. So this is actually equal to 24.8. So this is the mean. Next, we have to calculate the mode. Okay, so in order to calculate the mode, so if we refer to the formula for the mode, so this is LK plus D1 over D1 plus D2, and then you times them with C. Okay, so firstly, we need to know where is the mode. So find out where is the highest frequency. So the highest frequency of them is around here. So this is your highest frequency, 24. Okay, so the lower boundary for them is 20 because we have 20 plus 20 over 2. So that is my lower boundary, which is 20. D1 is actually the difference between this frequency and the one before that. So 24 minus with 15. So the difference for them is actually 9. D2 is the difference for this frequency and the one after that. So 24 minus with 18. So that is 6. The class size. So the upper boundary is 25. The lower boundary is 20. So the class size is simply equal to 5. So we're going to substitute everything and then let us see what is the value of them. Okay, so 20 plus 9 over 9 plus 6 multiply with 5. So your mode is 23. So we have already calculated the mean, we have already calculated the mode. So we have already been given what is the standard deviation. So now let us calculate the Pearson coefficient of skewness. Okay, so the formula for them is SK equal to mean minus mode over standard deviation. Okay, so the mean is 24.8 minus with 23 over 6.798. So we have 0.265. So we need to be very careful what is the sign for this one. So the sign over here is actually positive. So that means they are actually greater than 0, or you can say that this is positively skewed. Okay, so the distribution of daily income is skewed to the right, or you can call them as positively skewed. Normally, I prefer positively skewed because if I have positive, then positively skewed. If I have something with negative, then negatively skewed, and so on. Okay, let's see. Do we have any other example? Okay, so no more. So that means we finish with chapter 6. So I'll give you a 2 minutes break, and then we are going to start with chapter 7. Kelakar lah budak ni. Sabar je lah. Aduh, hai. Orang lain ada lagi ke kat sini lah? You guys yang lain ada ke kat sini? Ada. Okay, very good. Masih bertahan lah semua orang. Masih bertahan lah. Nak masuk permutation and combination jap. Nyawa ikan, ya Allah, kesiannya nyawa ikan. Sat lah, saya pun macam dah nyawa-nyawa ikan dah. Saya pun nak kena refill energy jap. Asyik tersasul je baca nombor tu tak. Cuba bertahan. Me too, Amran. Lagging ke Akmal? Tengah lagging lagi InsyaAllah bertahan. Okay kot, sebab yang ni dalam around 14 slide. So I guess sekejap sajalah boleh siap saya rasa. Dalam 5.45 macam tu settle kot. Pening lalat. I'm sure that it's gonna be overwhelmed with all those formula sebab dia banyak sangat formula kan. So kadang-kadang mungkin kita akan rasa macam terlalu banyak benda. So that is why I told you better to take one A4 paper, write down the formula for the group data on the left, write down the formula for the ungrouped data on the right, so that you can easily refer and look at them every time you want to do some question. So lebih baik macam tu lah. Senang sikit daripada kadang-kadang kita baca terlalu banyak benda kan. And then do make sure to add the formula for the standard deviation and the variance as well sebab kita baru belajar hari ni. So do add for the variance and standard deviation too. For Pearson coefficient of skewness, you can share them for both. Pearson of coefficient of skewness tu dia boleh guna untuk dua-dua. So dia macam kat bawah lah. So atas ni asing, bawah tu macam dia seorang je. Okay, so now let me proceed with chapter 7, permutation and combination. So actually this is one of my favorite topic. When it comes to the second semester, this is actually one of my favorite topic. We can give a lot of question, a lot of thing to do and to ask and to wonder, to think a little bit. Okay, so now let us proceed straight away. Okay, so the first one, 7.1 permutation. So today basically just a few recap on how to do permutation, and then I think we're gonna spend around 2 hours for the permutation and then another 1 hour for the combination. Okay, next. At the end of the lesson, you should be able to use the technique of counting and then find the number of permutation for n different objects. So we have different object or distinct object, and then find the number of permutation of R object from n different object, and then find the number of permutation of n object comprising of R1 identical object, R2 identical object, Rk identical object. Okay, so basically what does it mean is that we have, let's say, something like a word. So for D, that simply mean I have something with identical. So ada benda yang sama lah, contohnya macam huruf kan. Let's say we have this sentence. So I have an identical F and I have an identical E as well. So those are what we mean by identical. Okay, so firstly, the technique of counting. Okay, so if an event has m step, of which the first step can be performed in n1 different ways, the second is in n2 different ways, the third in n3 different ways, then the whole event can be performed in n1 times with n2 times with n3 times with n m different ways. Okay, so basically let us see example 1. In a computer game, there are 2 tunnels leading from point A to point B. So you have A to B. Basically, you have 2 tunnels going from A to B. 3 tunnels from point B to C. So I have 3 over here. So this is B to C. And then I have 4 from C to D. So 1, 2, 3, 4 to D. Calculate the number of route to move from point A to C via point B. So I want to go from A to C. So the number of ways, so from A to B, the number of ways is 2 because I have 2 different ways. B to C, I have 3 different ways. So the number of ways will be 2 times with 3, which is 6. And then for B, I'm going from point A to point D, and I must pass through the point B and point C. So A to B, I have 2 ways. B to C, I have 3 ways. C to D, I have 4 ways. So the number of ways altogether is 2 times 3 times 4, which is 24 ways. Okay, so that is example 1. Next, the definition of permutation. So a permutation is an ordered arrangement of subject without repetition in a set of object. For example, there are 6 permutations of the letters A, B, and C. So for example, ABC, ACB, BAC, BCA, CAB, and CBA. So we can either start with A first, or we can start with B first, or we can start with C first. So basically there are 6 permutation. So normally for them, I'll use some box to represent. So this is the first place, this is the second place, this is the third place. So if let's say I have 3 choices for the first one, and then another 2 choices for the second one. This one I have one choice for the last one. So 3 times 2 times 1. So that is how we come up with 6. Okay, I'm sure if we see the example, it will be much more easier. Okay, so the number of permutation of n different object taken all at a time without repetition. So for this one is without the repetition. Okay, so it's supposed to be NPN, or you can write them down using n factorial. So n factorial is actually NPN. So that is actually n multiply with n minus 1, multiply with n minus 2, multiply with dot dot dot, multiply with 2, multiply with 1. Okay, so it's like I'm having 7 subject and I want to arrange all of them. So 7p7. So out of 7, I want to arrange all 7. So it's supposed to be 7p7, or you can easily write down 7 factorial. Okay, so one note, 0 factorial is actually equal to 1. The second one, npn is equal to n factorial, means that the product of all the integers from 1 to n inclusive, n is called the n factorial. So this one over here is called the factorial. Okay, basically, how many different 4-digit can be formed from the digit 5, 6, 7, 8. Right, so basically we have 4 different numbers and I want to get 4-digit numbers. So I have 4 place and I have 4 things to arrange. So this one is definitely 4p4. Or you can say that this is actually 4 factorial, which is 24. So 4p4 or 4 factorial, and this is 24. Okay, the next one. The number of permutation of R object taken from n different objects. So just now, if let's say I have 4 things and I want to arrange all 4 of them. So now, if let's say I have 4 but I just want to arrange 2, or perhaps out of 4, I just want to arrange 3 of them. So that is what they mean over here. Okay, so the number of permutation of n different object taken at a time is npr, where npr is n factorial over n minus r factorial. Okay, so this one, please highlight them. You're going to use them a lot, especially when you need to prove something. So do make sure to highlight this one. So npr is equal to n factorial over n minus r factorial. Okay, so if there is no restriction, repetition is allowed, then the number of ways is n to the power of r. Okay. How many 3-letter words can be formed from the letters in the word absolute? Okay, so let's see. Do we have all different letters, or do we have something that is repeating? I don't have any other A. This is B, the only B, the only S, the only O, the only L, the only U, the only T, the only E. So every letter only come out once. So dia tak ada yang muncul banyak kali kan, semua muncul sekali saja. And basically I want 3-letter words. Okay, so let us see how many N do we have here. So 1, 2, 3, 4, 5, 6, 7, 8. So altogether, I have 8 of them. And I want a 3-letter word. So that means this is R equal to 3. So that means the number of words is 83. So this is 336 words. Okay, next. There were 7 empty seats when 4 passengers boarded a bus. In how many ways can they be seated? Okay, so we have 7 empty seats. So that means the n is actually equal to 7. 4 passengers boarded. So that means R is equal to 4. So out of 7 empty seats, 4 of them must be seated. So this one is 7p4. Or you can easily calculate them to become 840 ways. Okay, next. Permutation of an object comprising of R1, R2 until Rk identical object. So always make sure when you want to do some permutation, check do you have something with identical or not. If you have something with identical, it will be a little bit hard to calculate them because we need to be extra careful. Okay, so the number of permutation of an object comprising of R1 identical object, R2 identical object, RK identical object, R1 plus R2 plus RK is equal to N is N factorial over R1 factorial, R2 factorial, up until RK factorial. So this is actually the thing that is identical. Okay, so for something with identical, so N is the total things that you want to arrange. So N factorial over how many of the things that are identical. Okay, let us see the example for this. Identical objects are objects that cannot be distinguished, like the letters P in P, P, A, P, and so on. So that means if, let's say, you change the place for the P on the last one with something on the first one, so you change the place for them, but the letter is still the same. So that is why we're gonna call them as identical. Dia tak ada beza pun kalau kita ubah kedudukan dia. Macam saya ubah daripada belakang pergi depan, pergi yang nombor dua, because they are the same letter. So even if I change the place, it will keep giving me the same word. Okay, next. Find the number of arrangement for the following word. Okay, so let us see how many letters do we have over here. Okay, so 1, 2, 3, 4, 5. So N is actually equal to 5. So how many L? I only have one L. And then I have two O. And then I have two T. So that means I do have something with identical, which is the O and the T. So the number of arrangement is 5 factorial over 2 factorial, 2 factorial. Okay, so 5 factorial, this is all of them, arrange all over the thing that are identical. So this is the n factorial, and then the thing that are identical. How many of them that are identical? Okay, so let us try for the B. So mathematics 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the n is actually equal to 11. How many m? 1, 2, so 2m. And then I have 1, 2a. And then 1, 2, so I have 2t. And then h, I only have one of them. And then the E, only one of them, one E. How many I? One I, one C, and one S. So 1, 2, 3, 4, 5. 5 plus 6. So this is exactly equal to 11. Okay, so the total number is 11. So it's supposed to be 11 factorial over. So I have identical M, identical A, identical T. So it's supposed to be 11 factorial over 2 factorial, 2 factorial, 2 factorial. So we got 3 of them. Oh, just now the answer is 30. I forgot to give you the answer. The answer is 30 just now. Okay, so this one, 11 factorial over 2 factorial, 2 factorial, 2 factorial. Another one, what is that? Oh, 2t, 2 identical t. So 2m, 2a, 2t. So 11 factorial over 2 factorial, 2 factorial, 2 factorial. And the answer for this one is 498,960. Let me see, do we have any other question after this? No, we don't have any other question after this. This is basically the last one. The end of lecture 1 of 3 for chapter 7. Easy, right? So we only have around, I only spent around 10 minutes for them. Okay, that's good. Right, guys, so I'll see you guys tomorrow. We have a lecture tomorrow at 2 o'clock. So I'll see you guys tomorrow. In the meantime, do make sure to try to revise your chapter 6. If you still have some problem with some of them, then you can come and see me tomorrow. Or you can text me first. So text me first and then boleh lah kalau kata nak deal, nak jumpa ke apa ke. if let's say you want to ask something, so don't be shy to text me. Okay, so I'll see you guys tomorrow. Thank you very much. Enjoy your day everyone. Pergilah makan dulu ke apa ke, kesian korang. Okay, bye-bye.